This is the Falkirk Wheel, the world's only rotating boat lift. On their journey between the two canals, boats are lifted or lowered 24 meters. Yes, this video may be animated, but this is a real place in Scotland. In this video, we're going to learn how it works with a complete tour of the inside machinery. People come from all over the world to see the Falkirk Wheel. It reminds me of Tower Bridge in London, the famous bridge that's still in use today. The Falkirk Wheel may not be as famous, but maybe it should be. It has two gondolas, also called caissons. These are filled with water and transport the boats up and down the wheel. You'll often see one or two boats traveling on each side. One side travels up as the other side travels down. When the wheel finishes rotating, a watertight seal is created. The gates are lowered, and the boats can exit onto the canal. Now, what is this strange wheel doing in the middle of Scotland? We've got to go over a few things before we can see how the Falkirk Wheel actually works. And there's some things about the wheel that I did not expect. But first, let's get some background here. Let's come over here to Europe and zoom in a little farther to get to the country of Scotland. Then we have Scotland's two largest cities. A long time ago, if you wanted to ship goods in between these cities, you had to take a boat, and it was quite the journey. Since water was the best way to transport goods, they dug two canals, the Forth and Clyde Canal and the Union Canal. The problem is that the canals are two different heights. This is a simple example, but you get the idea. How do we get the boats to go in between them? This is called a boat lock, and it's basically a water-powered boat elevator. It's often used when connecting two waterways at different heights. Here's what a boat lock in Scotland looks like, and in fact, they still use these today. There's the lock chamber and the gate doors on each side. When water needs to be released from the chamber, they'll open up the paddles in the gate. When a boat goes through the lock, it will enter the chamber and the gates are closed behind it. On the upstream side, they'll open a mechanism to allow the water to flow around the gate. This is called a sluice. The boat will slowly rise over just a few minutes. And then the other gate can be opened for the boat to continue on its way. And of course, the lock works in the other direction too. Well, this is why the Falkirk Wheel was built, to lift and lower boats between two waterways. But the wheel is referred to as a rotary boat lift because it moves boats in a circle. Before we had the wheel, things were a little different. In the 1800s, they connected these two canals with boat locks. And actually, to be specific, there were 11 boat locks in a row. They call this a flight of locks. Remember that these canals are not at the same level. There's a 34-meter height difference between them. That's about as tall as a 10-story building. It's high enough that we use not just one, but 11 of them. It took a whole day to get through. It's a long time, but there's no other way to get between the canals. The locks were used up until the 1930s. They fell into disrepair, and within a few decades, the canals were closed completely, which means it was no longer possible to travel by water across Scotland. This brings us to the Millennium Link project. This was a project in the 1990s to restore the canals and reconnect them. The place that this would happen is a town called Falkirk. But we can't just restore the 11 boat locks. They were filled in and built over. Instead of a traditional boat lock, they wanted something that could become a landmark. Some of these early concepts were very creative. This one had an overhead rail system to lift the boats. Interesting. Another design looked like a seesaw, and I'm not sure how it would have worked. Sounds kind of dangerous. And this design looked like a Ferris wheel with 4 cars. They seemed to really like the idea of a boat lift that rotated. They finally settled on a design that looked like this. It includes several elements inspired by Scottish culture. Construction started in 1999, and the wheel took 3 years to complete, costing around £17 million. The Falkirk Wheel opened to the public in May of 2002. It's visited by more than 500,000 visitors every year. This building is the Visitors Center, and over here is where they control the Falkirk Wheel. The boats get off and can travel along the aqueduct. That's the part that holds the water high above the landscape. To get to the Union Canal, they'll go through Rough Castle Tunnel. The reason this tunnel was built was to preserve the remains of an old Roman wall that's about 2,000 years old. Coming out here on the other side of the tunnel, you can turn a corner and go through 2 more traditional boat locks. Below the Falkirk Wheel is another boat lock to take you all the way to the Forth and Clyde Canal. So today, here's the modern journey between the two canals. So now you might ask, who actually uses the Falkirk Wheel? In the 1800s, they used the canals to transport goods like coal, iron, timber, and grain. But today, the Falkirk Wheel is mostly used by tourists and boaters who want to enjoy the canals. As a tourist, you can purchase a ticket and come wait in this area here. There are 2 tour boats that run all day long. They'll take you up the wheel, let you enjoy the scenery, go through Rough Castle Tunnel, and then turn around and ride the wheel down again. The whole trip takes about an hour. If you're feeling adventurous, you can actually take your own boat through here or rent one to experience things firsthand. This is called a narrowboat, and they're quite common on the canals here. Some people choose to live in them full time, and I've heard they can be quite cozy inside. We're going to look at how the wheel works in detail, but first let's plan a hypothetical trip. And because typing is a little bit slow, I'm going to use a product called Whisperflow. What this will allow me to do is say it all out instead of typing. So here we go. We're visiting the Falkirk Wheel, so here's our to-do list. Number 1, buy tickets in advance. Number 2, arrive 30 minutes early. No, wait, actually 1 hour early. 3rd, take photos of the Falkirk Wheel. And 4th, grab lunch before going home. Notice how it corrects the mistakes mid-sentence and even gets unusual words correct. Okay, so this was done with Whisperflow, the sponsor of today's video. This is a voice-to-text tool that works anywhere that you're doing work, as long as it has a text box. On average, you can talk about 4 times faster than you can type. Other dictation tools work, but it can take time to correct all those mistakes. With Whisperflow, it's different. Let me show you. I'm doing this on the computer, so I hold my hotkeys, I see that it's recording, and now I just talk. Hey Sean, for our next space video, I need you to finish that research on Dexter and the Canadarm. If it gets a word wrong, you can correct it and it will remember for next time. I've been using Whisperflow for a few weeks now and it saved me so much time while I work on upcoming videos. Give it a try, get 1 month free of Whisperflow Pro by clicking the link below. Now let's take a look at how the wheel operates. Let's imagine we're in the lower basin and we're going to ride the wheel up. The boat is slowly guided onto the gondola. There will be operators nearby to help. There's a few things that have to happen before the wheel can rotate. The first is to separate the water. We've got to contain it inside so it can't escape back into the basin. So let's look at some parts here. These are the arms of the wheel, and they work together to hold the 2 gondolas. When the lower gondola is docking or undocking down here, keep in mind that the upper gondola will be doing the same thing up here. Same process in both places. Okay, now let's look at just one of the gondolas. It's like a giant bathtub, but there is a gate on each side. In this view, they hold the water inside, but when the arm is docked, one of the gates will be lowered so water can flow in and out. Right underneath the wheel, this is the area that the arm travels through. There's a lot of machinery to connect to the gondola when it's not moving. And in fact, there's another room here that allows access to more of the machinery for the pumps. Let's look at one of the parts that's a little hard to see. It's called the hydraulic lance. If we look back at the gondola, there is a hole where the lance will connect. It supplies the high pressure fluid that causes the gates to rotate. Once the arm swings into place, it's a little hard to see everything, so let's get a closer look. To separate the water from the basin, we rotate the gate on the gondola side, and then a second gate on the basin side. Now we've got a little space in between the gates. This water is pumped out of the area. Then the watertight rubber seal is retracted. The water is fully separated, but the wheel can't turn yet. There's a few more parts to disconnect. The hydraulic lance will be retracted. Then there is a hydraulic clamp. This can move up and down. Looking at just the gondola again, you can see this part sticking out the bottom. This is what the clamp will hold onto, firmly holding it in place when the wheel is not moving. But since we're undocking, it's time to retract the clamp. The final connection point takes place in both of the pits here. Let's take a closer look. These are called the securing pins. These hold the arms in place. If you look closely on one of the arms, you can see a hole on the outside. They have them on the other side as well. When the arms swing down, the securing pins move in and hold it in place. But since we're getting ready to rotate the wheel, the securing pins will be retracted. After all of this, the wheel is finally free to rotate. Because the wheel is balanced on both sides, it takes a lot less energy to turn. That's about the same amount of energy to run a dishwasher through a full cycle. The wheel can rotate in either direction. The operators alternate directions so the parts wear out more evenly. It takes about 5 minutes to spin the wheel 180 degrees. At the top, we have the same mechanisms: the docking clamp, hydraulic lance, water pumps beneath, and a gate on the aqueduct side. I like how you can actually see a lot of this machinery when the wheel is in motion. Once at the top, the docking process is reversed from what we've seen before. The arms are held in place by the securing pins at the bottom. Then the docking clamp holding the gondola in place. The hydraulic lance extends, then the watertight seal, and water is pumped into this area. Then the gates on each side are lowered, and the boat is free to exit. Because water travels up and down with the gondolas, almost none of it is lost. A traditional boat lock uses a full chamber of water every single time a boat passes through. The Falkirk Wheel uses almost nothing. The same water just goes along for the ride. Now let's get to balancing the wheel. This is the strange part. A boat can enter one side while the other side is still empty. And guess what? The wheel is still perfectly balanced. But how can that be? Let's look at one of these old balance scales. When you put a boat on one side, the scale should now tip because that side is now heavier. So is there something different about the Falkirk Wheel? Well, what's going on here is a little more difficult to see, and it has to do with the water. This goes back more than 2,000 years ago to a Greek mathematician named Archimedes. He realized that when you put an object in water, like this floating boat, it pushes some of the water out of the way. Now, the water that was there in this space, let's compare it side by side to the boat. Surprisingly, the boat and the water displaced weigh exactly the same. This is called Archimedes' principle. On the Falkirk Wheel, when a boat floats into the gondola, it pushes some of the water, which ends up spilling back out into the canal. On the balance scale, this is like removing a few coins as we add the boat. If we remove just the right amount of coins, then the scale will still be balanced. It's harder to see here, but when you add a boat, you lose the same amount of weight in water. The gondola weighs the same as it did before. This is why the wheel is always balanced, even if one side is empty. Now that's neat. Now onto the gears. This is actually the reason that the gondolas stay perfectly level. They don't tip even in the slightest. Imagine if the gondolas were firmly attached to the side. It would rotate along with the wheels, but we obviously don't want that. On the bottom of the gondolas are wheels that run on tracks. This helps, of course, but it's not enough to guarantee that it's always upright and never tips at all. Let's come around to the backside here. This is where you'll see the gears. We have a central gear, 2 idle gears, and then 2 ring gears on the outside. The gears don't spin the wheel. The spinning of the wheel is done by the motors on the inside here, but we'll take a close look at that in just a minute. Let's start with just the central gear. It's fixed in place. You can think of it like being glued onto the pillar. So when the wheel spins, the central gear does not. Okay, now we have the 2 idle gears. These will slowly rotate around the central gear, spinning in the same direction that the wheel is spinning. Now for the ring gears. They will spin in the other direction. What that means is that the wheel spins in one direction and the ring gears rotate in the opposite direction. Now watch the 2 ring gears on the outside as we play this in fast forward. The gears stay level the entire time. It's all mechanical. Since the ring gears are attached to the gondolas, guess what? They never tip. No matter how the arm is rotated, the gondolas will always be perfectly upright. The last part of our video is the final pillar. The aqueduct full of water is held up by the support pillars underneath. The one at the end here is called the final pillar. You can actually pay to take a tour inside, and the doors are right here. Let's take a look inside. It contains several interior chambers, or levels, connected by ladders, and inside them is everything needed to run the wheel. This is the ground level, and then up above is level 1, 2, 3, 4, and 5. Let's start with the ground level. It houses equipment for the main incoming power for the wheel. The ladder is here, and that will take us up to level 1. This has the standby generator and equipment to switch to backup power if needed. Up above is level 2. There's a door in the back that leads to a close-up view of the gears. It also has control panels that act as the brains of the whole wheel. Now let's climb the ladder to level 3. This is the mechanical heart of the structure, and you can see it's the biggest chamber. It has the hydraulic pumps, and these supply the 10 hydraulic motors. This is what actually turns the Falkirk Wheel. They also act as the brakes too. If we look inside, you can see they spin the 10 small gears, which then spins the larger rack gear on the outside. This spins the central axle, which spins the wheel. This all happens because of the tiny motors inside of here. You'll notice a ladder that goes right through the center. If you go through here, you can actually walk through the center axle. It's about 3 meters wide in here. If you walk all the way through, you'll come out on the other side and get some amazing views. Back to level 3 here, you'll notice a yellow crane. It actually pokes out through this opening in the wall here. This allows equipment and replacement parts to be lifted up from the ground. It's how they get large machinery inside the pillar. Once inside, floor panels open up to lower the equipment down to the level that it's needed on. Now let's go up another ladder to level 4. It has another door which leads outside. And if we come outside here, you can see that door is another place to access the gears. And finally, we have level 5. Another crane up here to lift equipment to the top 2 levels. This ensures that we can get heavy items all the way up to that top level if we need to. Level 5 also has machinery to operate the gates at the top. And if we zoom out a little bit, you can see that we're right underneath the aqueduct. Level 5 connects with all the other mechanisms that we saw earlier in the video. Level 5, you can climb some ladders and keep going up until you finally have reached the top. The fresh air right next to the edge of the aqueduct. This is the Falkirk Wheel. My name's Jared, and on this channel we explore bowling alleys, donut machines, inside famous buildings, and even how space stations work and keep astronauts alive. Thanks for watching this video about the Falkirk Wheel. You can watch another video by clicking here.